Hello. So today we are going to discuss properties of solid. In this unit we are going to study about the different properties of solid. Mainly we will discuss about stress and different types of stress like tensile, compressive, shear and the strains and also the different types of strains like tensile strain, compressive strain, shear strain, and after that we will discuss the stress strain graph in detail and the various properties involved with the stress strain graph. So let's start. First, we are going to discuss about the concept of deforming force. So deforming force can be defined as it is the force which displaces a body from its original position or configuration either by changing location or shape. For example, we can discuss a pencil which is broken by applying a force. So deforming force is the external force which anyone applies on any body and it will disturb the shape, size or configuration of the body. Now comes to restoring force. Restoring force is the force like it tends to move the place of body back to its original position or configuration. For example, we can take the sponge ball. So the restoring force is the force of the body which try to back the body in the original position. So after removal of deforming force, the body applies itself a restoring force and the restoring force tries to take the body back to its previous position which was which was before application of deforming force. Now we are going to discuss the concept of elasticity and plasticity. Elasticity is the property of solid material by virtue of which it tends to regain its shape after the removal of external load. Whereas plasticity is the property of the solid material by virtue of which it tends to retain its deformed shape after the removal of external load. In elastic deformation, although atoms of the solid are displaced from their original lattice site, they return back to their original position once external loading is removed. So atoms are temporarily displaced in case of elasticity. Now coming to plasticity in second point, in plastic deformation, atoms of the solid are permanently displaced from their original lattice site. They retain the new position even after removal of the external loading. In elasticity, the amount of elastic deformation is very small, whereas the amount of plastic deformation is quite large. External force required for elastic deformation of solid is quite small, where in the case of plasticity, the force required for plastic deformation is also higher. Hooke's law of elasticity is applicable within the elastic region, and Hooke's law is not applicable if the material is plastically deformed. Most solid materials display a linear stress-strain behavior within this elastic region. A stress-strain curve is non-linear in the plastic region. In the elasticity, the energy absorbed by the material during the elastic deformation is called as modulus of resilience. Whereas in the case of plasticity, the total energy absorbed by the material during elastic and plastic deformation region is called modulus of toughness. Elastic deformation occurs prior to plastic deformation, and plastic deformation occurs only after it is elastically deformed. Mechanical and metallurgical properties of the solid material remain unaltered, or it can be say unchanged, when it is elastically deformed. But in the case of plasticity, the many properties of the solid material change considered by considerably for plastic deformation. So elasticity is an important consideration for machine tool structure, bridge, other civil frames, equipment body, and many household structure and frame that should retain their shape. And plasticity is an important consideration for sheet metal working, various forming operations such as rolling, forging, extrusion, etc., and rivet joining. You can see here clearly by the picture we can understand the difference between elasticity and plasticity. The rubber, which is the first diagram, top one is the elastic material rubber, which can be stretched, and after removing the force, the rubber will gain its initial position. This is the property of the elasticity. It is the elastic material properties which is elasticity. When you can see that it is a pin which is made of steel, and if you deform the shape of the pin, it will not regain its original shape. This property of material is called as plasticity. Now we are going to discuss stress. Stresses are expressed as the ratio of the applied force divided by resisting area. Mathematically, stress is denoted by sigma is equals to force per unit area. The unit of stress is Newton per meter square, which is also called as Pascal. 1 kilopascal equals to 10 is to power 3 Pascal. 1 megapascal equals to 10 is to power 6 Pascal. Type of stress. Broadly, the stresses are categorized into two types, which is normal and combined. Further, normal stress is classified into two types, tensile stress and compressive stress. In the combined stress, there are two more further classifications, shear stress and torsional stress. Normal stress. The resisting area is perpendicular to the applied force. In the case of normal stress, when you apply the force, the resisting area which the area which resists the force is perpendicular to that applied force. Tensile stress. It is a stress induced in a body when it is subjected to two equal and opposite pulls, that is the tensile force, that is also called pulling force, as a result of which there is tendency in increase in length. It acts normal to the area and pulls on the area. And now compressive stress. Stress induced in a body when subjected to two equal and opposite pushes, as a result of which there is tendency of decrease in the length of body. This is also called pushing force. It's act normal to the area and pushes it on the area. See here we have seen two clear diagram. Compressive stress, there is a two pushing force which is acting on the body. In the case of tensile stress, two pulling forces which has equal amount which acts perpendicular to the resisting area pulls the body. This is the difference between tensile stress and compressive stress. Normally in the compressive stress there is a pushing force of equal amount from both the ends. In the tensile stress there is a pulling force of equal amount from both the ends. Now another classification of stress is combined stress. The combined stress, a condition of stress that cannot be represented by a single resultant stress, is called as combined stress. First one is the shear stress and second one is the torsional stress. There are two examples, two subcategory of combined stress. First one is the shear stress, second one is the torsional stress. We are going to discuss here shear stress. Shear stresses arise when forces act tangential. Keep in the mind tangentially. So shear stresses arise when forces act tangential to the surface of the body in opposite direction. Shear stress makes the body to deform or cut. Like scissor and punching machines are the best example of shearing. The shear stress tau is equals to force per unit area. Torsion. Torsion occurs when an object such as a bar with cylindrical or a square cross section as shown in figure is twisted. The twisting force acting on the object is known as torque and the resulting stress is known as shear stress. This is the example. First one you can see when you apply the tensile stress, how the body fails. Second one is the compressive stress. You compress the body from both the end. And third one is the shear stress in which the forces act tangentially on the body. A strain. Now we are going to discuss the concept of a strain. When a body is subjected to some external force, there is some change in the dimension of the body. The ratio of change in dimension of body to its original dimension is called as a strain. A strain is a dimensionless quantity. So, when you apply some external force on a body, there will be change in the dimension of the body. So, the ratio of change in the dimension to its original dimension means the dimension which is before the application, which is prior to the application of that external force, is called as original dimension. So a strain is a dimensionless quantity. Now we are going to discuss the some terminologies which is related to a strain. First one is the longitudinal or linear strain. A strain that changes the length of a line without changing its direction. It can be either compressional or tensional. Compression, longitudinal strain that shortens the object, it means you apply the push force. Tension, longitudinal strain that lengthens the object, it means you are applying the pull force. Shear, a strain that changes the angle of an object is called as shear strain. Shear causes lines to rotate. Infinitesimal strain. A strain that is teeny, a few percent or less, is infinitesimal strain. It allows a number of useful mathematical simplifications and approximations. Finite strain, a strain larger than few percent, requires a more complicated mathematical treatment than infinitesimal strain. Homogeneous strain. Homogeneous is the uniform strain. A straight line in original object remains same. Parallel lines remain parallel. Circle deforms to ellipse when you apply the homogeneous strain. Note that this definition rules out folding since an originally straight layer has no remain straight. Homogeneous strain. How real geology behaves. Deformation varies from place to place. It is called inhomogeneous strain, in which the way the real geology behaves. Deformation varies from place to place. Lines may bend and do not necessarily remain parallel. These are the properties of inhomogeneous strain. So types of strain. There are four types of strain: tensile strain, compressive strain, volumetric strain, and shear strain. In the next 6 slides, we are going to discuss these strains one by one. First one, we are going to discuss tensile strain. Tensile strain, the ratio of increase in length to the original length of the body when it is subjected to a pull force. Tensile strain is increase in length upon original length, which is also called as dl, which is change in length upon L. So when you apply a tensile stress, that is a pulling force at both the end, the length of the object will increase. So tensile strength can be calculated by change length, that is increase in length upon the original length of the object. Compressive strain, you can see in the diagram. Compressive strain is the ratio of decrease in length to the original length of body when it's subjected to push force. So generally in the case of compressive strain, the length of the body will reduce. So compression strain can be given by decrease in length upon original length, which is dl by delta L by L. Now volumetric strain. Ratio of change of volume to the original volume is called as volumetric strain. So change in total volume upon volume is the volumetric strain. Suppose we have a rectangular box which has the dimensions B, D and L. So volume can be given as L into B into D. Change in volume can be given as change in length, change in width and change in depth. So change in length into B into D, delta LBD plus delta BLD plus delta DLV. Now we can take common of LVD from the right hand side and LVD equals to V. So we can divide V in the whole equation. Delta V by V equals to delta L by L plus delta B by B plus delta D by D. So delta V by V is called as epsilon Y equals to epsilon X plus epsilon Y plus epsilon Z. This is called as volumetric strain. Now shear strain. A strain which produces due to shear stress is called as shear strain, and shear strain is denoted by gamma. So shear strain is the deformation upon original length. So it is very important how you take the positive and negative sign in the consideration of a strain. So tensile strain are considered positive in case of producing increase in length. Compressive strains are considered negative in case of producing decrease in length. Hooke's law. Hooke's law says within elastic limit, the stress and strain are directly proportional to each other. The constant is known as modulus of elasticity or Young modulus or elastic modulus. Mathematically, the Young's modulus E or modulus of elasticity E is equals to a stress by a strain. Young's modulus E is generally assumed to be same in tension or compression, and for most of the engineering application has high numerical value. Typically, Young modulus E equals to 210 into 10 is to power 9 Newton per meter square for steel. It has a different value for different material. Now a most important topic we are going to discuss here is a stress strain diagram. We are putting the stress on y-axis, vertical axis, strain on horizontal axis. You can see the diagram here. O to A is the proportional limit, B is called as elastic limit or yield point, then B to C, then C to D and D to E. E is your fracture point. After point C, the material will show the plastic behavior, and before that material will show the elastic behavior. So we are going to discuss this diagram in detail. The stress strain curve can vary with the material in question. With the help of such curves, we can understand how the material deforms with increasing load. So generally the stress strain curve defines the deformation of the material with the increase in load. Now we are going to analyze this curve. In figure, we can see that in the region O to A, the curve is linear. Hence, Hooke's law obeys in this region. It means as the load increases, stress and strain behaves directly proportional to each other. So the region O to A shows the linear graph. In the region A to B, the stress and strain are not proportional. However, if we remove the load, the body returns to its original dimension. So O to A is the proportional limit. In this limit, stress and strain are directly proportional. But A to B, that is not the linear relationship, but the elastic limit exists till the point B. If you remove the load till the point B, the body will regain its initial position or shape size of the initial. There will be no permanent fracture till the point B. The point B in the curve is the yield point or the elastic limit, and the corresponding stress is called as yield strength, which is denoted by the SY. Once the load is increased further, the stress is starting exceeding the yield strength. This means that the strain increases rapidly even for a small change in the stress. The point B, this is shown in the region from B to D in the curve. If the load is removed at any point, say at point C between B to D, the body does not regain its original dimension because it has exceeded the elastic limit. You will see the mark of permanent deformation on the body after the B. Hence, even when the stress is zero, the strain is not zero and the deformation is called as plastic deformation. So, as the load increases beyond B, the body will start deform gradually, and if the stress becomes zero, strain will not be zero and deformation will be called as plastic deformation. Further, the point D is called as ultimate tensile strength of the material. Hence, if any additional strain is produced beyond this point, a fracture can occur at point E. So, the distance between the point D and E also tells a very important property of the material. The ultimate strength and the fracture point are close to each other, point D and E, then the material is called as brittle. If the ultimate strength and fracture point are far apart, points D and E, then the material is ductile. Now we are going, that was the stress strain diagram for a ductile material. Here we are going to see the stress strain curve for an elastic material. Stress strain behavior varies from material to material. Rubber, for example, can be stretched up to several times its original length and still returns to its original shape. The figure below shows the stress strain curve for the elastic tissue or aorta or recent in the heart. The figure shows the stress strain curve for elastic tissue of the or the large tube vessel which carries blood in the heart. From the curve you can observe that while the elastic region is very large, material does not obey Hooke's law. Means there is no linear relationship between stress and strain. Also, there is no well-defined plastic region. Materials like rubber, tissue or the aorta, etc., which can be stretched to cause large strain are called elastomers. Modulus of elasticity and its types. In the stress strain curve, the region within the elastic limit, which is region OA, is of importance to a structural and manufacturing sector since it describes the maximum stress a particular material can take before being permanently deformed. The modulus of elasticity is simply the ratio between stress and strain. Modulus, elastic modulus can be of three types: Young's modulus, shear modulus, and bulk modulus. First, we are going to discuss Young's modulus. Young's modulus is the ratio of the tensile or compressive stress to the longitudinal strain. Unit of Young's modulus is Newton per meter square or Pascal, which is the same as that of stress. Shear modulus. Shear modulus G is the ratio of shearing stress to corresponding shearing strain. Another name of shear stress is the modulus of rigidity, which is denoted by G. Bulk modulus. We have already studied that when we submerge a body in a fluid, it undergoes a hydraulic stress which decreases the volume of the body, leading to a volumetric strain. Now, bulk modulus is the ratio of hydraulic stress to the corresponding hydraulic strain. Factor of safety. Factor of safety, also known as interchangeably with safety factors, expresses how much stronger a system is than it needs to be for an intended load. It is the ratio of ultimate strength of a member to the actual working stress or the maximum permissible stress when in the use. So the purpose of the factor of safety is to minimize the risk of part failure. Factor of safety N can be given as sigma U upon sigma W. Sigma W is the working stress, sigma D is the material strength. So this is the concept we have discussed today. Thank you very much.